Welcome back. I'm your host, Rich Weber, with the Florida Aviation Network. We're broadcasting live in the clear, which is a free service to you all, from the Howard Hughes exhibit in the Florida Air Museum at Sun and Fun 2013 at Lakeland Linder Regional Airport in Lakeland, Florida. And with me today, I have Mr. George Bartuska. He's with the Central Florida Aerospace Academy, and he's going to talk to us about the Astronaut Challenge. Welcome.
Thanks, Rich. We're glad to be here.
We're glad that you're here to talk to us about it. This is a pretty interesting project you have going on.
Absolutely. This was the second year for the Astronaut Challenge. It was created by Mr. Peter Carafano up at the State of Florida High School, which is part of Florida State University. He received a grant about 5 years ago, and they constructed a simulator of the Space Shuttle orbiter. And from that, they developed this competition where the students have to do 4 things during the competition. This year, approximately 40 teams throughout the state of Florida took the initial testing, and from them, they selected 7 teams, plus the team that won last year was able to bring back a team. Let me turn it over to the kids now to let you explain the 4 different parts of the competition.
Excellent. Now, you said with testing, so they had, each of the students had to take a test which was going to be like an aptitude test then for this project?
Actually, they were given a manual on systems in the Space Shuttle orbiter, astrophysics, aviation, because there's terrestrial flight. Let's remember that the Space Shuttle is the only vehicle ever made to date that was all 3, a launch vehicle, a spaceship, and a terrestrial aircraft, a glider that they flew back home. Even the Braun designed by the Soviet Union didn't have engines on it. Its launch vehicle was a separate part. So the Space Shuttle still is a very unique spacecraft.
And that's something that's interesting for our viewers to know about, of how, the kind of the makeups of the Space Shuttle, and like just what you're saying, that was an interesting piece of knowledge that's good to know.
Exactly.
That most people, I don't think, know about the shuttle. They just see it. They see it launch. They see it orbit, and then they see it come in and land.
That's
not
right.
knowing, what all it takes, and that's kind of a unique piece of space aircraft.
Right.
Great. Well, go ahead.
Mr. Abar, why don't you talk about the first 2 parts of the competition you want to talk about, and we'll let Mr. Roberts take the other 2.
My name is Alejandro Ibarmoda. Initially, whenever we started off with the competition, like Mr. Bartuska mentioned, we formed the team. We only had about 2 or 3 weeks to prepare for it. We had a study manual that involved some common knowledge that we already knew just based on going to the academy about the spacecraft itself, such as the components, as solid rocket boosters and external tank. But it did go a little bit more in depth as to other components, such as life support systems. And like Mr. Bartuska mentioned, we went over to Orlando and we had to take more like a qualifying test to see whether or not we would actually be going up to Tallahassee for the final part of the competition and compete against the other teams.
To find out what your knowledge was, and if you had the right stuff to be able to proceed to Tallahassee.
Yes, sir.
Excellent.
And it was a pretty cool experience, especially. We didn't have as much time to prepare as the other teams. The other teams had a couple months to prepare, and we only had a couple weeks. So to be able to go up there, based on what we knew and based on how long we studied, and to go up there and be one of those 7 teams that got to go up to Tallahassee is a pretty big accomplishment.
That's a huge accomplishment. So it took you guys had to buckle down and spend a lot of time burning some of the midnight oil, I guess, to get ready.
Yes, sir.
Excellent.
Yes, sir.
Good. So then from there, you guys prepared, you went to Tallahassee, you took the test. Now, then what's the next step after that before we go on?
Colin, you want to talk about that?
Yeah. Well, to get ready, we had several months to prepare, and one of the big things that we had to do to get ready was a proposal of an experiment to do in space. Our proposal, a design is right here, had to do with physiology in space and how to prevent deterioration of the bones in space, because that's one of the biggest problems.
Deterioration of bones in space?
Yes, sir.
Now, does that apply to anyone going to the moon, or does it apply more to other planets that, maybe Mars that hasn't been explored as much?
Everywhere outside of the Earth.
Anywhere when you get outside the atmosphere is where this can happen. And
it depends on the gravitational force of where you're at. If it's less than Earth, you will have some problems. If it's more, it might be harder for you to move around, so you wouldn't have to work as hard to stay fit.
Oh, due to the gravity or their lack of?
Correct.
So tell us a little bit more about the deterioration of the bones. It's some interesting news that I think a lot of our viewers may not even be aware of.
Well, in space, our bodies are basically free-falling, and so our bodies don't have to work as hard to do activities moving around the ISS. So because our bodies don't have to work as hard, they kind of lose their muscle mass and their density. Therefore, we have to compensate by exercising, which they exercise for, I believe, 3 hours on the space shuttle every day, which that could be a problem because it takes away from time of doing other things like lab experiments.
Some of the required tasks of what needs to get done while they're up there, and the reason why they're up there is for all these different experiments, projects, and different tasks that need to be done. So then taking 3 hours out of the day can really make it kind of time critical.
Exactly.
So what's the solution, do you think?
Well, we proposed a centrifuge, and this is actually one of our team members designed this, Stephen Trowbridge, on SolidWorks, and we printed it out on our 3D printer. The astronauts would go inside of here, which there are actually people in there.
Mm-hmm.
And basically what it does is it spins, and their bodies would be forced to the outside, therefore simulating gravity.
Just like going to the fair and getting in one of those gravity things that sticks you to the wall. As it's spinning around, it sticks you to the wall. This is going to have the same principle to kind of relate something to it.
Exactly.
Excellent. So, and how will that help with then the body, the bone mass and the deterioration of the bone mass? Because you say they need to exercise. Well, if they're in this and they're just spinning around, how does that work? Can you explain that? How that's going to keep from the deterioration of the bone mass and muscles?
Yes. And this is actually to be used while they're sleeping. That way, instead of getting in this for the 3 hours, they're in it while they're sleeping. That way, it adds time for other stuff on the ISS.
Absolutely. So they're going to be in this thing. Would this be something they'll be standing up?
Rich, there is no up.
True.
And let me just add a couple things. What they found out in their research is today we don't know exactly how the body senses gravity. Nobody's really put a finger on that yet. In addition, we do know that the body acts like a system, and thus wherever that sensing is going on, it ends up getting transmitted throughout the body. So the theory is here, using this technique while they're asleep, trying to let some part of the body sense gravity, along with possibly some pharmacological drugs that are used today for people who start to have osteoporosis.
Mm-hmm.
A combination of the two, there's a theory, and remember, this is just an experiment. And the idea is with the experiment we'd have a control group who wouldn't be in the centrifuge. And typically the crew on the ISS is 6 astronauts. Potentially 3 would use this for some period of time, and the other 3 would just sleep regularly. And we'd start to see maybe we could get a handle on what is the actual cause of this bone loss. Mm-hmm. Or what is the actual trigger in the human body that triggers that you are sensing some kind of gravity. Because that brings up the next point. Do we really need to simulate 1G? Or can we simulate a half a G or a quarter G if it's done all night long or for an 8-hour sleep period?
Like maybe a slow turn versus spinning faster?
Exactly. And then this flip side of that is, if the astronauts could tolerate it, maybe if we could spin them at 2 Gs, maybe not only would we prevent the bone loss, maybe we would promote bone growth. And there's another muscle mass part of this too, but that was the guts of the whole thing. They did a lot of research online to detect what was known today. Of course, there's been a lot of research done by NASA, but we're still kind of in a research mode overall to find out. Because as I mentioned to you before, it's one thing to go up into space for 6 months. The round trip to Mars is estimated to be about 16 months. That's a long time.
That's a long time to be in space, which is really could affect your bones, your muscles, and like wouldn't it, I guess you could say that's kind of like your muscles atrophy, like for lack of use.
Exactly. And as Mr. Roberts correctly pointed out, one of the big concerns of NASA is that they're spending all this time exercising to prevent a detrimental effect of going into space, and they don't have the time, or they're not having that time to do the mission they're up there to do. So in addition to that experiment, there were 3 other parts of the competition. There is what's called the Brain Bowl, where the teams compete against each other to answer questions. And there is practicing flying the simulator. Mr. Abar, why don't you go into that part?
Like Mr. Bartuska just mentioned, along with the proposed science experiment that we had to present to judges, there are 3 other parts of the entire competition. The space shuttle simulator was actually designed and put in a trailer, almost like a U-Haul trailer that you see people towing around. Inside the trailer, you have a pilot, a co-pilot, and a mission specialist, as well as a judge that sits inside with the 3 in there. Next to the trailer, there's a canopy, and inside that canopy, the remaining 2 members are mission control. They act as mission control. They have the same monitors that they have inside the trailer, and they communicate almost as if the mission control is communicating with the actual space shuttle on a real mission. While we're in there, we do everything that a normal astronaut would do, despite not having all the training that a regular astronaut would go through. And it was mostly based on our knowledge of the manual that we were given.
Mm-hmm.
So the ones in the space shuttle, the pilot, the co-pilot, and the mission specialist go through, and they actually go through a launch sequence, the pre-launch sequence, taking off from the tower, getting into orbit, deorbiting, and also coming back in and landing. And it was really interesting, and it really helped us with some teamwork, and let us get a feel for what it would actually be like to be an astronaut, especially when the shuttle program was still in use. And it was, I'd have to say, it was a great experience, and I enjoyed it very much. And I mean, if I could go back there next year, unfortunately I'm graduating this year, but if I could go back, I would definitely do it again.
And one
Excellent.
thing I'd like to add to what he said, we started out with a team. The team is 5 members plus an alternate in case somebody gets ill. And at the get-go, I told them, we will figure out who's actually going to fly the orbiter once we get towards competition, because I want you all to get together in a group and decide who is the best at flying this shuttle. Mm-hmm. And in our case, it ended up being Stephen Trowbridge, if I'm correct. And so that was a real good team-building exercise in itself. That having been said, the other part is the engineering problem. Mr. Roberts, why don't you talk about the engineering problem?
Well, we go into this room and not knowing what we're going to do, and we were given a problem, and we have to solve it. We had to work together as a team, which was a big part of the grading process, and there were several problems that we had to deal with. And then after we figured it out, we had to also present it. So we had to put it onto slides, and then we had to propose an experiment to the judges of the answers we found, and if we could do what was given to us.
So they gave you. Did you have any idea what kind of problems that you might be presented with ahead of time?
Just an engineering problem.
You just knew there was going to be any engineering problems, so you guys had to go in. They'd give you the engineering problem. Then you guys had to put your heads together, and were able to do any kind of research. Did you have any material or?
They gave us all the material we needed to find the answers.
So all you had was right there, but that's all you had. It wasn't like you had the internet where you could look up any of these things. Everything had to be out of the provided material.
Correct.
Excellent. So that was a big team working exercise.
And on top of that, if I can add, we only had 45 minutes to solve the problems, and I think we had 3 problems, the 3 separate problems that we had to solve. And
what kind of problems would they give you then?
The first one was I think a prograde type problem, mm-hmm. based on if the shuttle went out of orbit and it started moving in an elliptical orbit rather than a circular orbit. We also had one based on if we had enough runway to be able to take off use the 747 that the shuttle is piggybacked on and use that to take off. And I believe the third one was a time problem.
Yes, we had to figure out if we had enough time to reach our destination.
Yeah.
Because there's a lot of other calculations in there. I guess did they even were some of the possible problems like if they had any type of emergencies or malfunctions with the systems while either in transit or in orbit, as far as like, power problems, losing power or losing any type of, breathing, any of that. Some real life factors it could be if you were actually in that.
I'd say not so much in the engineering problem, because I was mostly solving like what we could figure out based on what we had in the manual. But back to the space shuttle simulator, definitely in that they actually we had a list of emergencies that could potentially happen, and the judge that was in the trailer with the co-pilot, pilot, and mission specialist would actually present an emergency, whether it be a hydraulic emergency, a smoke or cockpit fire, and there's actually a procedure that we had to go through in order to take care of it.
A checklist.
A checklist. Yeah, that's right. And if we were, and actually, I think the problem we had was an RCS, a reaction control system failure, and we tried to get it fixed, and we couldn't do it, so we had to abort the mission and directly go into deorbit burn and land back at Cape Canaveral.
Excellent. You've used some jargon there that's obviously you guys have, really done your homework to learn a lot about this, and it just reflects how well you've prepared for it and obviously deserving of where you're at so far in this.
Let me just elaborate a little bit on the specialization. The initial testing they had in October, like I said, was space shuttle systems, astrophysics, and general aviation. But once they passed that, then they were given a manual that had the reaction control system, the environmental control system, the electrical system, and electrical, environmental, and the navigation system. So the engineering problem could have come out of one or any of those four groups: RCS, electrical, environmental, or navigational. And the year before, the problem was all electrical. So this year they mixed it up a little, and who knows what it'll be next year.
But that's a big bank of knowledge and information that you guys have to know and be readily familiar with, even if you have the material that you can reference, but you still have to, you can't just, look at it blindly with not having any preparation. So that's really a good job that you guys did. What is the reactionary control system? What is
reaction control system? When do you want to take that?
The reaction control system is actually on the space shuttle, and it can actually be used to make attitude adjustments. The reaction control system, I think, from what I remember in the manual, it said that there was 14 to 16 RCS jets on the space shuttle itself. So it almost acts as smaller jets that allow for attitude adjustments and adjusting the shuttle.
So they're like reactors then that actually can change and maybe pitch the aircraft.
Yes, sir.
For the different attitude that you need to be able to maintain the orbit.
Yes, sir.
And then actually maybe re-entering the atmosphere and coming back in.
Yes, sir.
That all has to do with the reaction control system.
Yes, sir.
Interesting. So the shuttle is then also flies like an airplane, obviously, when they come back in. More of a glider, but you have thrust, you have engines. Good.
Well, I'll clarify that a little. Just to clarify, when the space shuttle takes off, it has three main engines that are connected to the external tank, along with the solid rocket boosters. And once you're in space, though, the shuttle has no more propulsion system other than the OMS section, which there are two engines mounted on the aft, along with the RCS system. Actually, any spacecraft we've ever sent into space or anyone sends into space has an RCS system, because once you're in space, it's the only way to position, whether it was the Apollo command module or the service module or the lunar module or the shuttle. But then to deorbit, the OMS engines on the rear of the shuttle are fired to slow it down, which is all you have to do to deorbit, is to slow anything down to the point where gravity can start pulling it back to Earth.
So when they get in space and they're orbiting, then, because I think there's a lot of the viewers that probably aren't really familiar with the shuttle other than seeing what it does, but not really technically knowing how does it orbit. Does it take thrust to continue to be directed in a certain direction?
That is an excellent physics question. Mr. Roberts, would you like to take that?
you repeat the question?
The
please?
continuous fall?
In other words, once the shuttle or any space ship that we've sent up, whether it's back in the Apollo days or up through the shuttle, once it gets into orbit, how is it directed? In other words, we're out there in no gravity, so something's got to keep it moving, and keep it directed. Is that there's thrust through the engines, or?
Well, let's say you shoot a cannon. Eventually, it'll gradually descend back down to Earth. If you shoot it fast enough, it'll get caught and it'll just keep falling. So it's almost as if it's trying to escape, but it won't let it, and it's like stuck in the middle.
Kind of like an equilibrium almost, where it's going to continue to maintain the altitude, if you will, for lack of better words, up in space, where it'll stay where it wants to, because they've got to go to some of these space stations, so they're obviously in a certain location that they've got to be able to maneuver to and position them there.
You actually bring up a very interesting point. The general public thinks that we're in a zero-G environment, but we're not really in zero-G, because just like the moon is going around the Earth, it is constantly falling. It's definitely under the influence of the gravitational pull of the Earth, which is why we always see the same side of the moon all the time, because the heavier mass is towards the outside. So that when you're in a spacecraft and you're orbiting Earth anyway, you're under the influence of gravity. You still have mass, you still have some weight, but you are falling. You are constantly falling around the Earth. And eventually, given enough time, you will come back to Earth. So periodically, there's adjustments that are made using the OMS engine to keep in the proper orbit that they want to be in.
That's where I was going with that, and that was what the question was. And
Good.
And I appreciate you answering that, because that's I think a question that, and you gave the answer to, that a lot of people just don't know and kind of take it for granted, I think, as well.
Exactly.
Not really knowing the physics and the engineering part of it, what keeps that spacecraft, the spaceship, the shuttle up in orbit and where it needs to be.
And the velocity of the orbiter in orbit is what? 17,500 miles an hour to stay up there around 200 miles high. Well, that's where the space station is. The shuttle could operate at different elevations.
Excellent. Well, there's just a lot to learn about the space program and the shuttle program, and you guys have really done your homework and have been able to provide a lot of information for us.
We might let Mr. Roberts just comment on the very last part, which was the brain bowl, because there's brain bowls in a lot of different competitions, but this one was pretty severe.
In the Brain Bowl, each of us had buzzers, and they would ask the question, and we had to buzz in. And they were given a few seconds to collaborate with the team, and then the team captain would say the answer, and then if they got it correct, they would get a point. If not, then the other team got a chance to
answer the question. So it was back and forth. So they would provide, say, your team with a question, then they give you like a certain amount of time that you have to answer. They give you like 2 minutes or something to come up with an answer.
Not that much time.
Less time.
15 seconds.
I think it was 15
believe.
seconds.
15 seconds. Did you have any material that you could reference for this, or was it all basically out of your brain, and why they called it?
It was all out of our brains.
That's why they called it a brain bowl, then, I guess.
It was good. And remember, the whole thing here is, I think we're doing a time check. The whole thing here is STEM, science, technology, engineering, and math. And the idea is this whole exercise is to apply everything they learn to a particular application, this application being space flight and terrestrial flight.
That's interesting that you mentioned STEM. We talked yesterday with the Think Global Flight people, and Ms. Rice, she was talking to us about that and with their students, and that was I guess that may be kind of a buzzword then, that
Absolutely.
the STEM. So where are you guys going from here now? What's next with the challenge?
Well, we'll start to form a team over the summer. One of the things that we weren't aware of, you can send more than one team for the initial competition and evaluation and selection process. So I'm hoping next year to have about 3 teams, and we'll see how we do.
So you're going to have to I guess, find out who's going to do their homework and who's going to do a little bit of research and study over the summer to get
Exactly.
prepared so they can meet the challenge.
Exactly.
Excellent. That's really good. What now? How many people will it take for a team then?
It's 5 people as the main team members, and there's 1 alternate, and the alternate, of course, has to know everything.
So that's 6 per team. So you're looking at 18 people that you may have. How many?
Exactly.
What kind of pool do you think that you'll have for that? How many potential?
We have 250 students right now. We're looking to go to 350 students next year.
Excellent. Well, George, it was a pleasure having you on the show today.
Absolutely.
We have learned a lot, guys. You did a great job with what you've done so far for the school and for the astronaut challenge and representing the school over there at the Central Florida Aerospace Academy. Keep up the good work and good luck next year. And sorry, we're just about out of time, but stay tuned. We've got more information. We've got some exciting shows coming up for the rest of the day today. So either stay there, watch our shows, or get up and come to Sun and Fun. There's a lot to see here, and we will talk to you soon.